Hi, welcome back. Today is day 3 of probability, and today we're talking about repeated trials. This topic happens to be one of my absolute favorite in probability. When we have repeated trials, we're using a formula here, and P is our probability of success, Q is our probability of failure. When I say success and failure, success is the outcome that we want. Failure is the outcome that we don't want. It doesn't necessarily mean success as in a positive and failure as in a negative. It just more or less means that success is the outcome we'd like to see and a failure is the outcome we don't want to see. So, the probability of exactly R successes in N independent trials is, this is a formula you need to memorize. It will not be given to you on the exam. So it's NCR, P to the R, Q to the N minus R, where N equals our total number. R is the number we want. Okay? That's just something we're going to add to the notes. And remember, we've learned this in the past, the phrase at least means, at least 2 means 2 or more. And at most 2 means 2 or less. Sometimes it helps if you think about it as money. If I say I have at least $5 in my pocket, that would mean I have $5 or more. If I say I have at most $5 in my pocket, you need $6, you're not going to get it from me. So let's try some problems. So number 1, a fair coin is tossed 4 times. Find the probability of tossing exactly 3 tails. Well, N is the total number of times the coin is tossed. It's tossed 4 times. R is the number I want. I want exactly 3 tails. P is the probability of getting tails, which is 1/2, because when you flip a coin, 1/2 is your probability. And Q would be 1 minus P. In this case, it's 1/2. So, kind of up here, P plus Q has to be equal to 1. So then we use our formula, N to the R, E to the R, Q to the N minus R. You must write this formula down every time you use it in your homework. I want to see it every time, because the more you write it, the better you'll get at remembering it. So I'm going to do 4C3, C is 1/2, to the R, which is 3, times 1/2, to the N minus R, which is 4 minus 3, which is 1. Something to remember is these 2 exponents always have to add up to N. On the calculator, I would figure out 4C3, and when I put that in the calculator, I get 4. And then 1/2 to the 3rd power. I wouldn't actually do that in the calculator. I'd raise 1 to the 3rd power and then 2 to the 3rd power. So I'd have 1/8. And then 1/2 to the 1st power is 1/2. Remember, that's a 4 over 1. So multiply our numerators together, we get 4. Multiply our denominators together, we get 16. Remember, in probability, we do not have to reduce. Okay, let's look at number 2. If a spinner is spun 5 times, let's just read what, not which, what is the probability that it will land in the green area 3 times? So, N, the total numbers we spin, which is 5. R is the total number we want, which is 3. P is the probability that it lands in green. And if I look at this, landing in green is 1/4. And Q is the probability it does not land in green, which is 3/4. So it's N to the R, P to the R, Q to the N minus R. So N is 5, C 3, P is 1/4 to the R, which is 3, times 3/4 to the N minus R, so 5 minus 3 is 2. Or I can look at it as these two have to add up to 5. And then I figure it out. 5C3 in the calculator is 10. 1/4 to the third power is 1/64. And 3/4 squared is 9/16. And then I multiply numerators, multiply denominators, I get 90 over 1,024. Again, I don't have to reduce. If you use your calculator, the calculator will give you the answers that are reduced. So as long as you have an equivalent fraction, your answer is the same. The way to determine if you have an equivalent fraction is to type it into the calculator and divide and see if you get the same decimal value. Alright, for number 3, the probability that Team A will lose is 2/5. What is the probability that they will win 2 out of 3 games played? So N is 3 total games. R is 2 that they want to win. P is the probability that they win, because we want to find out that they win. Okay? So in order to win, the probability of winning is 3/5. The probability to lose is 2/5. So this is 3/5. And then Q is the 2/5. So it is NCR, E to the R, Q to the N minus R. So it's 3C2, 3/5 to the second, and 2/5 the first. 3C2 in the calculator is 3. 3/5 squared is 9/25. And then times 2/5. Remember, that's over 1. 3 times 9 times 2 is 54. 25 times 5 is 125. Don't have to reduce. One more, last one. If a family of 5 children is selected at random, what is the probability that 2 of the children are girls? Well, N is 5 total children. R is 2 of them are girls. The probability that you have a girl is 1/2. Probability you have not a girl or a boy is 1/2. It's 1 out of 2. You have a 50-50 chance of having a girl. 50-50 chance of having a boy because you only have 2 options, a boy or a girl. This question gets a lot of people tripped up because they want to do 2/5 for P and 3/5 for Q. So be careful with it. Your P is the probability that the child is a girl. So it's NCR, E to the R, Q to the N minus R. NCR is 5, C2, P is 1/2 to the R, which is squared, times 1/2 to the third. 5C2 is 10 in the calculator. 1/2 squared is 1/4. 1/2 cubed is 1/8. And remember, that's a 10 over 1. Multiply straight across, I have 10 out of 32. I do not have to reduce my fractions with probability. the one and only time all year long that you do not actually have to reduce a fraction. Okay, I hope you enjoyed this. This part is pretty easy. These problems are actually kind of fun. Once you get the formula down and get the hang of it, you'll see it's not so bad. Tomorrow we'll do another day very similar to this. And then we'll only have one more day of notes for this unit. Alright, see you back tomorrow.